Assalamu alaikum. This question is on work and energy. A pendulum is pulled aside until the ball has risen 0.5 meters above the lowest point B. It is then given an initial speed of VA equal 3 meters per second, which is the speed given here at point A. The speed of the ball at the lowest point B is. So basically I have a pendulum, and this pendulum at two locations, one at A, initial one, and then as the pendulum will swing, it will reach point B. And the height of point A is 0.5 meters. And this pendulum is given an initial speed at A of 3 meters per second. So I need to find the speed at B. Now, this is clearly, since at the end of the question it said neglect air frictional forces or neglect air friction. So then I can use the conservation of mechanical energy law. Delta E should equal to 0, or EB minus EA should equal to 0, which will give that mechanical energy at B should equal to mechanical energy at A. Mechanical energy at A is made of kinetic friction at A, because there is an initial speed of 3 meters per second, plus potential energy A. The reason there is potential energy, that it depends on my choice of a reference point. So if I to take my reference point here to utilize this distance of 0.5 meters, then the potential energy at point B that I need to find the velocity at should equal to 0. So here is kinetic energy at B plus potential energy at B. This term will cancel out because there is no height here. So the kinetic energy at B is half mvb square. Notice that this is the unknown that I need to find, Vb, should equal kinetic energy at A, which is half the mass initial speed at A square, plus the height, and it's here positive because it's above the reference point. So it is mg multiplied by the height h. Notice here that there is no need to know the mass of the ball attached to the pendulum. So I can cancel out the mass term, and I can just rearrange my equation so that half Vb squared should equal, if I multiply by 2, I can even simplify it more. If I multiply by 2, then Vb squared should equal Va squared plus 2gh, which will give that Vb should equal the square root of Va squared plus 2gh. And Va squared is a 3 squared. 3 initial velocity at A is 3 meters per second, plus 2 by g, 9.8, by the height h from the reference point, which is 0.5. And this will yield a Vb of 4.3 meters per second. Thank you.